So I've set you a couple of questions on solving wave equations. What I'm going to do in this video, I'm going to work you through those questions, so show you how you approach the solution and see what answers you got. Quick refresher for you on the two questions I set. So the first one was a basic solve algebraically this trig equation 1, which we need to use our waveform for. The second one was a bit more elaborate and looking at more of a scenario based question. So the kind of thing we want to work up to and build our way up to getting to be able to solve. So let's have a look at these two. So the first one, solve algebraically square root of 2 sine theta minus 6 cos theta equals 2 for theta being somewhere between 0 and 2 pi. So again, working in radians just like our last example was. Now at this point, what we have to do is rewrite this in terms of a wave equation, or one of the forms of one of our wave equations, so that we get rid of the fact we've got a combination of sine theta and cosine theta. Now, if we had just one of the two trig equations, so just a sine, or a sine squared, we could write it as a quadratic in terms of that trig function. But the fact we have a mix means we can't solve this singularly for a single function, so we have to use one of the waveforms to write it as that. Now, it doesn't tell you which form to use, so at this form you could technically use any version of the wave equation you want. Your values for the k and the alpha will be slightly different depending on which version you pick, but you should get the ultimate same solution for theta. Now what I'm going to do is I'm going to pick k cos of theta minus alpha. That's the version I'm going to use, but you could use any form of it. So k cos theta minus alpha equals k cos alpha cos theta plus k sin alpha sin theta. And I equate it to this here, looking at the coefficients of both terms. So coefficient here and here. And what I'm able to say then is that k cos alpha is equal to negative root 6 and k sin alpha is equal to square root of 2. So what I'm now able to do is take the pair of these and stick them together and figure out what tan alpha is. Well, tan alpha is sine over cos, so it's root 2 over negative root 6. What that simplifies down to is negative 1 over root 3. Now think back to your exact values table. Tan alpha of negative 1 over root 3 can be calculated using that. Now first thing you have to do before you do any calculation is figure out what quadrant it is in using your CAST diagram. Well, cos is negative, so it's our T and our S. Sine is positive, so it's our S and our A. And the tan is negative, so it's the C and the S for that, which means all three lie in the sine, so that's the quadrant we want. So we want to find what tan minus 1 of negative 1 over root 3 is. Well, what we want to first do is what tan minus 1 of 1 over root 3 is, using our exact values, so that's pi by 6. We then do, because it's in this quadrant here, 180 or pi, take away the pi by 6. When we do that, we get that alpha is equal to 5 pi over 6. Next step we then have to do is figure out what our k is. Now, our k, in this case, is the coefficients squared, added together, and then take the square root. So it's the square root of root 2 squared plus negative root 6 squared. So root 2 squared is just 2, root 6 squared, sorry, negative root 6 squared is just 6, so it's then equal to the square root of 8. Now that can be simplified using surds to 2 root 2. Or we could leave it as root 8. Either version is fine, we just want to keep an exact value. So what we're then able to do is say fine, so square root of 2 sine theta minus root 6 cos theta can be written as 2 root 2 cos of theta minus 5 pi over 6, and this can be substituted into our equation to put that equal to 2. So what we now have to do is solve that equation as we would a normal trig equation. So to solve it, we just take it like we would a normal trig equation and work it through. So divide by 2 root 2, we then get that cos of theta, take away 5 pi over 6, equals 2 divided by 2 root 2, which simplifies to 1 over the square root of 2. We then take cos minus 1 of this. So we then know that theta minus 5 pi over 6 equals cos minus 1 of 1 over square root of 2. Doing that is pi over 4. But what we need to make sure we do is take this for the other solution as well. So we know that pi over 4 is one solution. We then have to take it for our second solution too. So if we think about the periodicity of cos, our second solution, because it's positive, if you look at the curve, occurs along here. So 360 take away the pi over 4, or 2 pi take away pi by 4, so 7 pi over 4. Now there's an issue with this though. If we add on 5 pi by 6 to this, it pushes us up out with a 360 degree, i.e. our 2 pi range. So what we have to do is make sure that we get both solutions. So what we also have to do is remember the curve goes down this way, and we can also get a negative pi by 4. So what this means is we can actually disregard this solution here. Sometimes that can occur. You've got to think ahead with these sorts of questions. So now I can take theta minus 5 pi over 6 equal to pi by 4 or negative pi by 4, and then calculate them from there by adding the 5 pi by 6 to both sides. So I've got two solutions, pi over 4 plus 5 pi by 6, and the negative pi over 4 plus 5 pi by 6. Doing both of those, I get that theta equals 13 pi over 12, or 7 pi by 12. I get my two solutions for that. Now that puts them back into a range. We have to take this into account. Yes, sometimes if it was just theta equals that, great, this would be our second solution. But it's not. We have to take into account what correction we're going to do after this point. Bear that in mind. So our second question was the scenario question. So the research student observing a wave tank using this formula, so 1.5 plus 2 cos 30t minus sine 30t. H is the height, t is the time in seconds. Overflows if it exceeds this. When is it in danger of overflowing for the first time? Now it's the same idea as the first one. We've got a combination of trig functions, the cos and the sine, so we have to get rid of that and combine them and make them into one. So focus on that section first. Focus on the 2 cos 30t minus sine 30t. Let's look at that and try and get rid of that. And what I'm going to do is try and put that in a form k cos of 30t take away alpha. I'm going to try and put it in that sort of form there. Now k cos 30t minus alpha can be expanded, and we get k cos alpha cos 30t plus k sine alpha sine 30t. And then we can use this the same way we would before, equate our coefficients, figure out our k, figure out our alpha, and take it from there. So we know then that k cos alpha, equating it to here, is equal to 2. K sine alpha, equating it to here, is equal to negative 1. From there, tan alpha is sine over cos, so it's negative a half. Look at our cast diagram again, and let's determine where our solution for the alpha part lies. Cos is positive, C and A. Sine is negative, T and the C, and tan is negative, so it's the C and the S. All three lie in that quadrant there. So there is the quadrant our solution lies in for this one. So tan alpha equals negative a half. So alpha equals tan minus 1 of negative a half. Again, remember to do this, tan minus 1 of a half gives you a solution. Because in this last quadrant, we take it off of 360 degrees. Once we do that, we get an answer that alpha is equal to 333 degrees. Then we can find k. Look at the coefficients here again. K is going to be given by the square root of 2 squared plus negative 1 squared. 2 squared is 4, negative 1 squared is 1. K is therefore the square root of 5. Again, it's a square root. Leave it as the third form. Don't take it out just now. So what I can then say is therefore 2 cos 30t minus sine 30t equals root 5 cos of 30t minus 333 degrees. So I've rewritten it in this form. So what that now allows me to do is take this and substitute it back into this equation. So I can then say, fine, so my original equation now becomes 1.5 plus root 5 cos of 30t take with 333 equals the height. So that's me now got the equation in a form I can work with. So now that it's in that form, I can work with it. Now I know the critical height is when h equals 3.5. So if I substitute that into here and solve the equation, I can find when it's going to hit that critical point. So I can then say that square root of 5 cos of 30t to equal 333 plus the 1.5 equals 3.5. That's where my critical height is going to occur. So take this and solve it like an equation. I then get the cos of 30t to equal 333 equals 3.5 to equal 1.5, which is 2, divided by root 5. So I get 2 over root 5. What I can then do is take it from there and do cos minus 1 on both sides. So I then know that 30t to equal 333 is equal to cos minus 1 of this, which gives me negative 26.6, or 26.6. Now again, I'm taking into account the fact that yes, the curve has a periodicity like that, and I'll get a solution here and here, but I'm adding on 333 degrees, so this is going to shift up this way and out with our limit and our range that we want. We want the first 2 points within the 0 to 360 degrees, so I've got to take into account the fact that when I do add the 333 on, this one will move up into our range. So 30t minus 333 is equal to these two. Add on the 333, I get that 30t equals 306.4 or 359.6. Divide both by 30, I then get that t equals 10.1 or 11.9. So I've got two answers there, perfect. Well, what I now have to do is put that back into my scenario. So what I can then say is, therefore, the tank will overflow. So the tank is at risk between 10.1 seconds and 11.9 seconds. So the tank is at risk for the first time in those two, between those two times. Now this is the kind of question we have to be able to get to the standard of answering. This is what we want to be able to do in this higher course with this wave stuff. So hope that wasn't too complicated and taxing for you. I'll see you in class for a bit more work on this and any help you need to get.